The causes of head or cylinder failure are often due to lack of lubrication or a cooling system malfunction. Loss of either oil pressure or coolant flow can mean total and catastrophic engine breakdown, as overheated parts deform, fuse, or separate. When an oil pressure or a coolant temperature gauge or warning indicator shows an abnormal oil pressure or coolant temperature, they should be considered correct unless further testing proves them to be inaccurate. If engine oil pressure is actually low, check the grade of oil being used and inspect the oil pressure bypass valve first, before considering opening the engine. Inspect the filters, screens, and inlet pipes for obstructions, and then check the pump output. If pressure is below specifications, check the crankshaft bearing clearances. If the bearings are within specification, replace or repair the oil pump. A milky gray sludge in the oil filter or coolant in the oil pan is an indication of a possible cylinder block coolant leak, cylinder sleeve O-ring leak, or an oil cooler failure. A continuous supply of clean oil is necessary to protect all moving parts, but particularly critical to high RPM turbocharger bearings. When inspecting the lubrication system, make sure to check the flow of oil through the turbo bearings. Coolant leaks will eventually cause higher coolant temperatures, but are often evident before then. Periodic checks of the coolant level and inspection of water hose connections and thermostat housing will generally indicate coolant leakage long before the temp gauge rises. When replacing or replenishing engine coolant, always use a mixture of 50% drinking water to 50% ethylene glycol coolant. This mixture is the recommended formulation by most manufacturers to protect the engine against overheating and freezing. Remember to add the supplemental coolant additive, or SCA, to achieve the specified protection level. Adding the correct amount of supplemental coolant additive, or SCA, is required when replacing engine coolant. High engine operating temperatures may be caused by obstructions inside the engine cooling passages or outside the radiator. This will prevent airflow from transferring heat from the engine to the atmosphere. If the engine overheats, but the coolant level is okay, check the thermostat. The thermostat may also be a problem if the engine does not quickly reach normal operating temperatures. Higher than normal coolant temperature with no loss of coolant or obstruction to coolant flow may indicate possible problems with fans, shutters, and shrouds. Make sure these devices operate at the proper temperatures. Preventive maintenance of the lubrication and cooling systems is insurance against sudden and catastrophic system failures that often lead to engine damage. Perform oil and filter changes on schedule and inspect the coolant condition, replacing the additives and replenishing with the proper mixture on a regular basis. Also, a frequent check and, if necessary, replacement of coolant hoses and accessory belts keeps trucks on the job and out of the repair shop.